Hey everybody, Justin here. Thanks for checking out this video. I wanted to do a video on an article I wrote for my website, and this is called Digit Preference Heaping. So a heap is just like a pile, okay? And this is some R code I wrote to handle digit preference heaping. And I was following, this is like originally it was around 2009 when I wrote this, and I was following some article, and I cannot for the life of me find it. I think it was in the American Statistician. I really don't remember. If you find it, let me know. But this is like a digit preference is like the phenomenon of people reporting numbers that end in a certain digit. So kind of the typical example is people reporting their weights in numbers that end in 0 or 5. Like, for example, I have here, you weigh 173 pounds. Some people will report 173. Very rarely people will report like in half a pound. I weigh 173.6 pounds, But most people would report 170 or 175. So you see heaping around 0 and around 5 with weights. And this is I would say it's a more of a theoretical issue. It's it's a very practical issue, but it's more theoretical, I say, because in practice, in surveys, we often accept estimates. So, you estimate your weight, estimate your salary, estimate your whatever sales. I mean, if you have the exact number, that's fantastic, but we accept estimates. So often some people will report low, some people report high, some people report exact. In general, it's mostly those kind of average out, um, or they get adjusted by some statistical method or whatever. But I think it's both a theoretical issue and a practical one. So it just depends on how much heaping there is, really. Now, so this thing I was following, this article, they talked about kind of spreading those numbers out. So I'll show you what I mean. So in this example, I have three histograms here. The first one is the original data. So this is like the truth, I guess. And I'm just saying people are going to be heaping on numbers that end in 5. So say they're reporting their weights, and instead of, you know, reporting with zeros on the end, they tend to report fives on the end, right? So the 173, they would report 175. But this first histogram is their actual true weights. Okay. Now, I know it's not like a bell curve here or whatever. I was just coming up with like a toy example. And what I do in my R code is then I create the second histogram, which is taking 70% of the, let me see what I do here. I change 70% of the numbers ending in 4 to make them end in a 5. I kind of randomly do that. So if there's like a 184, I would randomly take 70% of those and change it to 185. So that's why you see that now in the second histogram, you start seeing the heaping at the numbers that end in 5, at 175, at 185, at 195. Because I'm pushing numbers from, 174, 184, and 194 over to the numbers that end in 5. So the second histogram is the one with the heaping issue. Now the third one is when I try to adjust the data. I call this adjusted data. So now I'm taking that, what I call the extra 5 data, the second histogram, and I'm trying to smooth it out to look like the first histogram. And so you can see the 175, the 185, the 195 are now a little smoother. They're more comparable. Actually, it's kind of like a halfway point, right? Between the first histogram and the second histogram. The tricky thing is some of those reported numbers that end in 5 are going to be valid, the actual numbers, right? Sometimes people report 175 and they weigh 175. But some of them will be the erroneous, overestimated or rounded up, whatever you want to call it. There'll be those numbers. Like they're really 173s and they got put in the 175 bucket. So you want to spread those ones out, right? So you want to spread out, you want to smooth the heaps, but not too much. Like I would not want this last graph to look exactly like the first, because it's just not realistic. You're not gonna get it exact to what the truth is, right? But I would like to have a lot of the lumps at numbers that end in 5 kind of taken care of as much as possible. So let me go to the R code, and I have some comments here. So first I just generate a bunch of data between 170 and 200 pounds, and these are all uniform. That's why it looks like a flat bars there. And then I'll add in numbers ending in 5. So I take 70% of the numbers ending in 4 and make them into 5. And I have a note here. Now I want to spread out these extra, but probably false, but maybe true numbers ending in 5. And on average, I want to keep them around the true number because they may be valid. Okay, so I have this parameter, this 0.1. Okay. And I end up spreading out 40% of the numbers that end in 5. Okay. And if the original measurements are thought to be too small or too large, you can make the low and the high endpoints asymmetric. In other words, right at this point in the code, using the parameter of 0.1, you can change that according however you want it, right? So I spread out 40% of the numbers ending in 5. Now again, you don't want to spread out too much and you don't want to spread out too little, because in the first scenario you'd be moving data that should be there. In the second scenario, you're not moving data that shouldn't be there. So this is probably very data specific, very application specific. So in this example, I could make it whatever I wanted to, but in reality, you'd probably want to do some research into this parameter and how much of the data you're moving around. Okay. And then I actually move it, and then I make the histograms. Now, I noticed that when I do this, this adjustment procedure preserves the mean, which is desirable, but it does add to the variance. You can think of that, you're kind of adding noise to the data in a sense, right? And here we're doing it kind of symmetric up or down, so I think it preserves the mean, but you are adding noise to it, so it will increase the variance. And I kind of show that by taking the means of and the standard deviations of the original, the extra 5 data, and the adjusted data, kind of, the means and the standard deviations, and show that. So I just wanted to share this. I think it's a very simple introductory way to talk about adjusting data when it's suspected that digit preference heaping has occurred. It's not very sophisticated, and there need to be some research behind this parameter that's used to get the adjusted data, and how much of the numbers that have been heaped, about how many of those you want to move, to spread out. But I thought it was interesting, so I wanted to share that, and I will talk to you later. Bye bye.